FastMCP3's component versioning mechanism enables maintaining multiple implementations of tools, resources, or prompts under a single identifier, with clients automatically receiving the highest version by default. This pattern supports API versioning scenarios where different client versions require distinct component behaviors without requiring separate deployments. The upcoming code demonstrates how a client can list available tools and inspect their version metadata, revealing both the current version in use and all available versions for each component. This discovery process allows clients to make informed decisions about which component versions to utilize. From FastMCP import client. Async with client server as client. Tools equals await client list tools. For tool and tools. If tool meta. Fastmc meta equals tool. Meta get fastmcp. Hash current version being returned highest by default. Print version. Fastmc meta get version. Hash all available versions for this component. Print available. Fastmc meta get versions. This code demonstrates FastMCP's version discovery mechanism, allowing clients to inspect available component versions before making requests. The pattern uses metadata injection to expose version information without modifying the core component interface, maintaining backward compatibility while enabling version-aware clients. The implementation follows a metadata-driven discovery approach where version components automatically include a FastMCP metadata object containing both the current version and all available versions. This design lets clients query the server once to discover all versions, then make informed decisions about which version to request. The metadata structure uses sorted version lists, highest to lowest, to simplify client-side version selection logic. This approach provides several advantages. It enables graceful degradation when newer versions introduce breaking changes, supports version-aware tooling and developer interfaces, and maintains protocol compatibility with non-versioned clients. The trade-off is slightly increased payload size for version components, though this overhead only affects discovery operations, not actual component execution. The pattern works particularly well for API versioning scenarios, where clients need to adapt to different server capabilities. Let's break it down. From FastMCP import client. Imports the client class from the FastMCP module, providing the entry point for interacting with FastMCP services. Async with client server as client. Establishes an asynchronous context manager for a client connection to the specified server. The async with statement ensures proper resource management, automatically handling connection, setup, and teardown. The client instance is bound to the variable client for use within the context block. Tools equals await client list tools. Calls the list tools method on the client object asynchronously and awaits its completion, storing the returned value in the tools variable. The method retrieves a list of available tools from the FastMCP client. For tool and tools. Iterates through each item in the tools collection, assigning the current item to the variable tool in each iteration. This is the header of a standard Python for loop that will execute the indented block below it once for every element in tools. If tool meta. Fastmc meta equals tool. Meta get fastmcp. Checks if the tool object has a meta attribute, and if it does, retrieves the fastmcp key from that meta dictionary. If the fastmcp key doesn't exist, it defaults to an empty dictionary. The result is stored in the variable fastmc meta. Print version. Fastmc meta get version. Prints a formatted string displaying the version information retrieved from the fastmc meta dictionary using the key version. The output will appear as version X, where X is the value associated with the version key in the metadata dictionary. This is a simple string interpolation that extracts and displays version data from the FastMCP metadata structure. Hash all available versions for this component. Print available, fastmcp get versions. Prints a formatted string displaying all available versions for this component by accessing the versions key from the fastmcp meta dictionary. The output will show available, followed by the list of versions stored in the metadata. FastMCP3's versioning mechanism enables seamless API evolution through metadata-driven discovery. The pattern uses a single identifier for multiple component implementations, with clients automatically receiving the highest version by default. This approach maintains backward compatibility while supporting version-aware clients through metadata injection. The code demonstrates this by first establishing a client connection, then listing available tools. For each tool, it inspects the FastMCP metadata object to reveal both the current version in use and all available versions. This discovery process happens through a single query, with version information structured as a sorted list to simplify client-side selection logic. The design balances flexibility with efficiency. While version components carry slightly larger payloads during discovery, this overhead only affects initial queries, not actual execution. The metadata-driven approach keeps the core component interface unchanged, ensuring compatibility with non-version clients while enabling version-aware tooling. This makes it particularly effective for scenarios where different client versions require distinct behaviors without separate deployments.
The version list flaunts every option, while the client blindly grabs the newest, like a buffet with one plate.